So I wanted to move into the human spaceflight side of things very quickly. Um, on the, I think it was the 13th of April, the latest resupply mission to the space station, the Dragon CRS-5, commercial or cargo resupply system 5, was launched on a Falcon 9, and this is what that looked like. I'll just very quickly talk about the mission itself. It was launch several thousand pounds of supplies to the International Space Station, including an espresso machine. So the astronauts will quit complaining that they don't have good coffee. And this is a closer up view of this, this rocket taking off. What I want you to notice are these things. These are actually legs that pop out when they're attempting to recover the first stage by having it land vertically on a barge. So this was, I think, 3 days after launch. The Dragon approached the ISS and was captured by the robot arm on the ISS and docked to the station. So that the mission itself succeeded, but now I want to talk about this part of the mission, which was recovering the first stage. And so this barge is about the size of a football field. This is a little over 300 feet in this direction. It's about 150 feet or so in that direction. And Elon Musk, the owner of SpaceX, has a good sense of humor. They've named this just. So here was a still image of the first stage. This is about 140 feet long. Coming down, there's the barge. And the next time step, watch carefully because it's the movie of the rocket actually coming in. Okay, and it came in, unfortunately, at a slight angle, and it tries so hard to stay upright, but can't quite do it, and kablooey. And so what the analysis of this so far says that they had a sticky valve. They were trying to throttle the first stage, and the valve was slightly behind what the commands were to it, and so that's why it did this sort of whoopsie at the end, where it sort of veered off to one side and then tried to correct itself. So let's watch that one last time. So you see it sort of wobbling back and forth. It's trying to get there, and let me show you the view from the barge itself. And so here comes the rocket. You can see that it did come in at is about a 10 or 15 degree angle, and it just wasn't quite able to stay upright. One of the legs collapsed, and it was lost. But you know, they're getting close, and the next launch to the space station will be in mid-June, and so they expect they're going to figure out what happened on this one, correct that. And they came a lot closer than they did a couple months ago, which was the last time they tried this, where they were just slightly off the edge of the barge, tried to correct, and it was slightly below it was too low, and it came in and tipped over because it sort of tripped itself on the way in. And here's a view of the barge when it was back in Jacksonville, Florida, in port. You see most of the rocket and the explosion ended up falling overboard, but they got some debris left to actually analyze. Okay, and the final story I wanted to do just happened in the last day. This was a launch of a Progress vehicle from Russia to the International Space Station. They typically launch 3 or 4 of these a year, and it can carry about 6,000 pounds of payload to the ISS. And so there's about 1,200, 1,300 pounds of fuel that get transferred to the ISS for its own onboard engines, and a fair amount of water, and then supplies for the crew, clothes, food, things like that. And so this was the liftoff from Baikonur Cosmodrome in Kazakhstan. Very nice liftoff, and initially they said everything was hunky-dory, that the Progress had separated on schedule. But then once they had a little bit of time to analyze the data, they found that there actually was a fairly major problem. So this is just a view of what the Progress looks like. It's a variant on the Soyuz capsule, which carries our crews to the ISS. The difference is this doesn't have separate modules. This is where all of the pressurized cargo goes, which would be normally where the crew would be. This would be the re-entry vehicle on the Soyuz, but it is actually filled with fuel for the station. And then this is where the solar panels and the propulsion system sits. And that would look like in orbit approaching the ISS. So that's what should have happened about 6 hours after launch. It should have been at the ISS and ready to dock. But in fact, what they saw once they turned on the onboard cameras was it was spinning about 12 or 13 revolutions per minute. They've attempted to communicate with it about half a dozen times since yesterday morning, and they're really getting nothing back from it. They're not able to command it. They did have indications that the attitude control system was offline. So it's been declared a total loss as of this afternoon. That's not a huge problem, other than the fact that we lost one of the American resupply ships last, I think it was October. The Cygnus blew up on liftoff. And so that's 2 out of the 4 systems right now that have failed. The next launch will be that Dragon launch in June, and that should carry up about 5,000 or 6,000 pounds of payload itself. Later in the summer, I think late August, early September, the Japanese are scheduled to launch one of their cargo vehicles, and so that'll help the supply issue. Right now, they've got about 45 days of surplus supplies on board the station. So they should be fine. They hopefully will find out what happened to this one quickly and be able to correct whatever the problem was and be back to flying within a couple of months. But that's life in the space biz. Occasionally the rockets and the spacecraft don't behave quite the way that we would expect them to. And the final thing I wanted to do is just put in a plug for a program that will be happening right after Memorial Day next month. So this is the launch of the Expedition 44 crew to the space station. And this is the crew. So Mark Kelly, and I'm sorry, my memory just failed me. There are 2 Russian members that were launched earlier in the month to the space station. These 2 fellows are going to be spending a year on the ISS. And then the crew that's launching the end of May, there's 1 Japanese crew member, a Russian, and this fellow, Kjell Lindgren. And he has a lot of connections to the Denver area. He graduated from the Air Force Academy. He got a master's degree at Colorado State University, and he got his MD in emergency medicine from University of Colorado Medical Center. So he will be doing lots of programs with us over the course of the next 6 months. And so to start with will be his launch from Russia on May 26th. And this is a Tuesday, early afternoon, so we'll be certainly doing a program in the museum if you'd like to see his launch. And then in probably October, he'll be doing a downlink from the space station to some schools in the area via the museum's Scientists in Action apparatus. And so those students will be able to have about a half-an-hour conversation with the crew on board the space station, with Lindgren in particular. He's taking a couple of artifacts from the museum onto the station with him. One is a Clovis point, a spearhead that is evidence for the first humans in North America from about 12 or 13,000 years ago. And he's also taking one of our uniforms from the Space Odyssey exhibit with him, as well as a patch from Space Odyssey. And then once he'll be on the station, if everything goes well, until early November. And once he comes back, we expect next spring sometime he's going to come and give us some presentations about his life on board the space station. So that's something to look forward to. And so I think at that point I'd better stop. Our next 60 minutes will be a few days after Memorial Day, so the day after that launch happens. And as always, it's a first come, first served.